Hello guys, welcome back to my channel. So in this video we will continue with the concept of RFE, uh, which basically means redundant feature elimination. Okay, so what do you mean by feature elimination? Let's try to understand with example. So let me print my data set. So as you can see, my data set is having 32 columns. Basically, it's 23 columns. It's 32 in number because of the dummy variables we have created. Okay. So uh, in this data set, there are 23 different columns. Okay. If you see earlier here, yeah. Let me print it here. Okay. Where I have merged all the data. Yeah. Now here. Here you can see we have 21 columns, and each column you can simply say as feature. Okay, you can simply say each column as feature. Okay, so to predict whether a person will churn or not, we will basically predict on the basis of these columns. Okay, so that's why we are calling it the feature. So what happens in redundant feature elimination? We train our model, or basically we pass this to the RFE, and RFE decides, RFE basically rank these columns. Okay, on the basis of their values and on the basis of like it ranks the column, which column is is having higher importance to predict our output. Okay, so let me go ahead and do the practical. In that way it will be like more interactive. Okay, so let me import the linear model from scikit-learn. Okay, so what I will say, from scikit-learn dot linear model import logistic regression. Okay, why we are importing logistic regression? Because stats model, if you see previously we have trained our model using the stats model, but stat models doesn't support this RFE, so we have to import this logistic regression. Okay, and I am making object of this, so call it logreg. Okay, means logistic regression, it's just a name, it's just a variable name, and I will make a object of this logistic regression class here. Okay, now we will import RFE also. Okay, so from sklearn is a separate in sklearn library we have a separate package called feature selection. Okay, and from feature selection you can import RFE. Import RFE. Okay, RFE. Now create an object of the same RFE equal to, and I will define my RFE. Okay, and here you will pass the model name, the model class, which is in this case is the logreg, and number of the features. So suppose we want to decide between the 15 columns, decide among the 15 columns, we will pass here 15, or you can say 15 features. Okay, now in the next line I will fit my model using this RFE. Okay, so I will say RFE equal to RFE dot fit. Okay, RFE dot fit, and we will pass our training data, that is xtrain and ytrain. Okay, xtrain and ytrain. Okay, now let's run this. Okay, so what happened till now, we have initialized RFE, we have initialized logistic regression, and we have trained our model using this RFE, and we have stored in the variable called RFE. Now we will see the ranking. So which column get what ranking, we will see here. Okay, so to see that, we are having a keyword in RFE, that is support. So we'll use that RFE dot support. If you print this, you will get a list basically, and a true simply means the column has been selected for the model prediction. false means column has not been selected for the model prediction. So if you train the model, you will use this column, this column, this column where the value is true, and you will leave the column where the value is false. Okay. So to see the name of the columns, to understand it, like to see the name of the columns, we will use the zip function here. So we will call list zip, and we will pass extend dot columns, name of the columns. Okay, comma RFE support, RFE dot support, sorry, RFE support, and RFE ranking, RFE dot ranking. Okay, let me print this first. So as you can see, we get tenure, name of the column, true. It means we are selecting the tenure column for our model prediction, and ranking is 1, means it's having the highest priority. Same for phone service, same for phone paperless billing. Monthly charges has not been selected, and the ranking is also 8. So we will not take this column anyhow, because the ranking is like 8, and it already has been marked as false, so we will not consider this column going forward. Okay, total charges we will consider in model training, senior citizen we will consider in model training. Okay, so this basically gives us an idea which column we should take for model prediction and which column we should leave for okay. Now let me go ahead and take all these column into a variable. So I will name this call equal to x train dot columns. Okay, x train dot columns, where column in RFE dot support, now RFE dot support, yes. Okay, so all those column which were in the RFE support will be get selected. So basically where the value is true, these all will be get selected and it will be stored in this column variable. Okay, I hope I am clear till this point. Okay, now let's go ahead and try to train our model using this using these columns. Okay, so let me copy paste my code here. So what we have done, we have created a stats model, and in stat model we have to add constant. As you have seen in my earlier video, I have explained why we need to do this. Okay, this add constant method. So I have simply add the constant, and I am training my model and storing into log m2, means log logistic regression model 2 variable. It's just the name of the variable, nothing else. And then I am fitting this model and I am storing into a rest variable, and then I am printing the summary of the model. Okay, so if you can see the summary. Okay, here the tenure coefficient is in negative and the p value is in 0, means the person who has been apart from a long time are less likely to churn. Okay, but if you see here the internet service fiber optic, here the coefficient is 0.7 and p value is around 0, means this is like the person is having fiber optic will are more likely to churn. Okay, so these kind of prediction you can see, you can do by this, by seeing this summary part. Okay, now let's do some prediction. Okay, let's do some prediction with our uh, prediction data, basically our test data. Okay, so what I will do, I will just print the predictions here. So you can see this is how the predictions are coming, which is obviously the output is not clear. Okay, you can see it's ambiguous for us. So to simplify it, what I will do, I will just reshape this array. Okay, just reshape this array, and we will predict something like, we will create a data frame basically with the churn probability and the customer ID. So I have created a data frame with churn, okay, churn probability and the customer ID. Let's print the data set how it look like. Okay, now we will add the prediction to this data frame. Okay, so where the prediction value is, where the probability is more than 0.5, we will consider that as true, and less than 5 will be considered as no. Okay, so you can see where the value is less than greater than 0.5, we have considered them as true, else we are considering them as false. Okay, now let's go ahead. Okay, now one important concept of when we train a model, we want to see the accuracy, we use something called confusion matrix. Okay, so we'll also understand the concept of confusion matrix. Okay, for this let me open my Excel. Okay, Excel, suppose, okay, so first of all, what is a confusion matrix? So confusion matrix tell us how well our model is performing and what is the accuracy of our model. So suppose a confusion matrix has first of all 4 quadrants. First one is true positive, then we have false negative, then we have false positive, and then we have true negative. Okay, so and let me write here actual, oh, sorry for the spelling mistake, actual positive, actual negative. Okay, now let's understand this. Suppose we have trained a model, and what the model is doing, it's correctly identifying the true values. Suppose we have trained a model to predict whether a person is having diabetes or not. Okay, so uh, it has correctly identified the person with diabetes, that we will put in true positive. Okay, and what is false negative? Suppose the person is actually having the diabetes, but our model is predicting as no, so that will be considered as the false negative, that we call as false negative. Okay, what are the false positive? Suppose a person is not having diabetes and our model is telling that the person is having diabetes, that we could keep in false positive. And the true negative basically means the person is having diabetes and not having the diabetes, and our model is also telling that the person is not having the diabetes. So these value will keep here in true negative. Okay, so there are the two green areas, this one and this one. These both are the correct values. Okay, and these both are the wrong values. Okay, these both are the wrong values. Okay, so let me summarize what I have just told you. TP, then we have FN. Sorry, this is a code one. Okay, let me write it here only. TP, FN, then we have FP, then we have TN. Okay, and what do we understand by TP? So TP basically, okay, let me copy paste. Okay, So TP means true positive, where number of correctly classified positive instance. TN is true negative, number of correctly classified negative instance. False positive basically means number of incorrectly classified positive instance. Okay, and FN means number of incorrectly classified negative instance. Okay, so in false negative, what happens? Actual value is positive. Okay, positive, and the model is saying negative. Model is saying negative. Okay, same opposite is this one. Actual value is negative, model is saying positive. Okay, here actual value is negative, model is also saying negative. Okay, here actual value is positive, model is also saying as positive. Okay, so we are okay. Now how to create confusion matrix in Python we will see here. Okay, so to create a confusion matrix in Python we use scikit-learn library again. So I will use scikit-learn import matrix. Okay, now we'll write something like confusion matrix is equal to matrix dot confusion matrix, and we will try will pass the white and red final churn values and white and final predicted values. So these are the actual values and these are the predicted values. We will pass to the confusion matrix and it will print the confusion matrix for us. So if you see, there are true positive value is 3255. Okay, so the actual value is positive, model is also saying positive. True negative, the actual value is negative, model is also saying negative. Okay, so to calculate the accuracy of the model, what we do, we sum these two columns, basically true positive and true negative, and we divide it with the sum of the all columns. Okay, so that will give us the accuracy of the model. So to do that, we can simply use a inbuilt function of Python, that is accuracy score. Okay, so let me copy that also, accuracy score. So our model is 81% accurate. Okay, from this data we can see that our model is 81% accurate. Okay, so enough for this video. Let's revise once what we have done till now. So first of all we have gone through the concept of RFE. What does RFE means? Okay, and we have done some feature elimination using the RFE model. We have trained our model. Okay, after training we have seen the confusion matrix, what a confusion matrix is, and how to calculate accuracy score in Python. And here let me write the formula for this one also. So if you manually want to like calculate the uh, accuracy, you can use this formula. Okay, so accuracy equal to TP plus TN divided by all values, means TP plus tn. Okay, let's not conclude. TP plus tn plus fp plus fn. So this is the formula of confusion matrix. If you want to calculate like manually, you can use this formula, or in there is also inbuilt function which we have already used. So if you calculate this way, you will get this value 0.81. Okay, so hope this you understood all these concepts. In this in next video we are going to see what is a VIF is and how it's like useful to our model. Okay, what is a VIF? We will go to VIF concept in the next video. Till then, bye bye.